Ketones. Ketones are molecules that contain what we call a carbonyl group. A carbonyl group. Okay, and what that is that within the carbon chain, somewhere there is a C double bond O sticking out of it. So for example, in a linear alkane, so here we have a chain of carbons. Actually, I'm lazy. Let's take off one of them. In the middle somewhere, we have a carbon which is double bonded to a oxygen atom, and the rest is filled in with H's. As we know, all carbons must have 4 bonds, so for this to be a hydrocarbon, we have to fill in some of these H's. Alright, so this thing here is referred to as a carbonyl group. Molecules that are in the ketone family have this group, and it's always located somewhere in the middle of a chain, never the first or the last carbon. You will see that sometimes in textbooks, ketones are given this symbol. You'll see the carbonyl, and then you'll see R and R prime. The letter R just refers to any carbon substituent joined towards that carbonyl group. It could be any length of a carbon chain. It could be 2 carbons, 3 carbons, whatever it is. The 2 R's could be the same length, or they can be different. So on the sketch here that I've done in the box, this would be my R group here, 1 R group, 2 R groups. Okay. The key thing to remember is that the carbonyl group, the C double bond O, is never on the first or last carbon, always in the middle of a chain. Later on, we'll learn about what compounds are called when that carbonyl is in fact on the first carbon. Okay, now the carbonyl group has some special properties. It is, of course, polar. It is polar because of the oxygen atom. And oxygen, as you know, is one of the top 3 most electronegative atoms in the table. It's F, then O, then N. So this carbonyl group gives the molecule a polarity, which means that it gives the molecule some special properties and special reactivities. Because it's polar, it has the ability to attract other polar bits from other molecules, thereby facilitating a chemical reaction. The carbonyl group also gives ketones a higher boiling point than usual because, of course, molecules that are polar can form dipole-dipole forces, which is a strong intermolecular force. Other facts about ketones: they are found in sugar molecules, in glucose, for example, and they are overall just very good for organic synthesis, which means it's a reactive component of a molecule, thus making the overall molecule reactive to be turned into other things. The naming ketones end in "-one". Okay, let's do a simple example to start. So here we go. There's my carbonyl group right there. Now, the ketone carbonyl group is the defining feature of its family, and when it's a defining feature, it gets priority, which means that when you number the chain, you always try to give the carbonyl group the lowest number possible. This means that for this particular chain, we're going to number it from right to left so that the carbonyl gets 3. If it were to go from left to right, it would be 1, 2, 3, 4, which is a higher number, so we don't do that. Get out of here, Greek. Oh no! There you go. Alright. How do we name this? Well, we must write the location of that carbonyl. In this case, it's on location 3. 3-. This is a 6-carbon chain, which is hexane, but instead of writing hexane, we're going to write hexanone. 3-hexanone. Let's add a branch and see how that changes the game. Okay. Same rules apply. We try to give the carbonyl group priority, which means in this case it is located on carbon number 2. Then we look at what branches are present and we name the branches. This is 4-ethyl. Then we finish with the main chain, which includes a carbonyl at position 2. So it's 4-ethyl 2-hexanone. This is pretty similar to the alkyne and alkene naming, where we had to write a number down before the root word. Right now, but the number indicates what that special feature is. Next one, let's add a few more branches. I'm going to draw the carbonyl facing downwards this time, just to show you that these molecules can be rotated in any direction, and you have to still be able to recognize them for what they are. Okay, carbonyl gets priority, so we're going right to left. We have a niner chain. We have two types of branches. We have ethyl and we have methyl. We're going to write the ethyl first because it is by alphabetical order. So this is 6, 7. There's 2 ethyls, so we write diethyl, followed by 4-methyl, followed by a number to say where the carbonyl is. It's on 3. This is a niner, so it's non-name, except now it's going to be non-unknown. Non-unknown. Okay. Next, let's put in a condensed structure just to remind you what condensed structures look like. You still have to know how to recognize them. Okay. Can you guess how many branches I'm going to put into this guy? Every time you see a CH, that's an indication of a branch. If there wasn't a branch, it would be a CH2, right? Okay, here we go. Carbonyl gets priority, so we have to go from right to left again. Wow, I guess I'm just used to going from right to left, eh? Okay. Branches. We got methyl, we got chloro. Chloro goes first because it's by alphabetical order. We have 2 chloro, dash 4, 5. There's 2 methyls, so we write di. Okay, 4, 5 dimethyl. Finish it off with where the carbonyl is. It's on position 3. Okay. Total chain is hexanone. And our last example. Wow, have I really gone from the right side every time? Wow, let's do from left to right this time. Just to change it up a bit. Okay. I'm gonna put a drone in here. Let's put it here. Okay. Alright, carbon 1. Again, this is 1 here. This is not a carbon because that's where bromine is attached. So 1 is over here. 2, 3, 4, 5, and 6. We write the branches first. The bromine is a branch. It is on carbon 1. This is 1 bromo, 3 hexanone. And we're done. Fantastic. Okay, so to sum up, what is a ketone? A ketone is something that has a carbonyl group in the chain. Carbonyl group means a C double bonded to an O. This carbonyl group must be in the middle of a chain, in other words, not on position 1, or first or last carbon, however way you want to think about it. The ending of the name of these ketones is O-N-E to mimic its family name. And that's all there is to it. Go out.